Hello everyone, my name is Yu-Dong Zhang, Associate Professor of Radiology from Nanjing Medical University. Today we would like to introduce the machine learning technologies for the prediction of the lymphoma metastasis in the prostate cancer. We know that up to 15% of the prostate cancer account for the lymphoma metastasis at surgery, and many the prediction tools such as MSK-CC nomograms and the Brigantine nomograms were proposed for the evaluation, but with the limitation. And the direct the MR staging has the very low sensitivity, making the room for the improvements. So in this study, we propose to develop the new prediction models for the end stage of the prostate cancer by integrating the clinical biopsy and MR findings using as machine learning analysis. We including the 2 to 18 input variables from the clinical characteristics and MR-based evaluations and the biopsy findings. We're training our models using the 3 machine learning classifiers such as the lasso regression and support vector machines and the random forest. We found that if using the direct MR evaluation, we only produce the 40% the sensitivity. That's very, very low. Secondly, we found that the direct MR findings such as the quantitative the initial values, the MR-based T-stage and A-stage coupled with the biopsy findings are important predictor of the lymphoma metastasis. Additionally, we found that MR-based models makes the improvements in the prediction of lymphoma metastasis. Our new model produces the higher AUC values and better net benefits as compared with the MSK-CC nomograms. If fixed with the number of ePLND missed radio less than the 3%, our new model produces the higher positive predictive values and a higher number of the ePLND spared as compared to MSK-CC nomograms. So we included that evaluation MR findings contributed to prediction of the lymphoma metastasis. Our new prediction models superior to the conventional nomograms allows to more than 15% the ePLND spared as cost of missing radio less than the 3%. That's all. Thank you.